Simplifying fractions. Let's take a look at some basic divisibility rules. We're not going to look at all of them. We'll just look at the ones that really pertain to what we're looking at. And divisible by. We're going to take a look at 2, 3, and 5, our first three primes, which we'll talk about here in a minute. It's divisible by those when, for the 2, this is where your last digit is 0, 2, 4, 6, or 8. For an example, if we have 116, if I look at my last digit, which here is 6, that means it's divisible by 2. Now 3. It's divisible by 3 when the sum of the digits is divisible by 3. And very extreme example here. This number here. If I add digits together, and when I say add them together, I'm talking like you're imagining a plus between them. So like a plus here, plus here, plus here, plus here, plus here. So 1, 2, 3, 4, 5, 6, that would give us 6. Now 6 is divisible by 3, so this entire number here was divisible by 3. So again, we're adding the digits together, see if that's divisible by 3. And for 5, the last digit is 0 or 5. Example that. This number here. Since last digit is 5, that means it's divisible by 5. Okay. Let's review a little bit about a prime. I'm going to write down the primes. 2, 3, 5, 7, 11, maybe 13. Now what you'll find is there's an infinite number of primes, but probably 95% of the problems in algebra revolve around these primes right here. Maybe the 13 is kind of pushing it. Most of them are these first 5. They try to keep them fairly small for the most part. Though you will run across problems that have 29 and ones beyond that. But those are the main ones we're going to look at. Now, to review what is a prime, the only numbers multiplied together to give you that number are 1 in itself. For example, a 3, the only two numbers multiplied together to give me 3 are 1 times 3. Compare that to 4. 4 would be 2 times 2. It would also be 1 times 4. So this is actually called a composite. Not that you need to know that. But again, prime, the only numbers that multiply together to give you that number are 1 in itself. Okay. Let's take a look at this first problem. I like to show these by example. It wants us to write the prime factorization of 48. Now, prime factorization just means that we're going to rewrite this as numbers multiplied together. And the only thing you can have are primes. Like here we got 1 and 3. 1's trivial, but 3 is prime. Okay. Now the tree diagram is probably the best way on this. So you start with your number and you have this branch off like this. You start with your first prime, 2. And you see if it's divisible by 2. Well, my last digit is an 8, so it is divisible by 2. 2, and then if I did 48 divided by 2, that would give me 24. Now 2's prime, so we circle it. And I work with the 24. We're still on the first prime, which is 2, and last digit is 4, so it is divisible by 2. 2 times 12. 2's prime, so we circle it, and work with the 12. We're still on our first prime, the 2, and the last digit is a 2, so it is divisible by 2. 2 times 6. 2's prime, so we circle it. And now we're on to 6. Still working with the first prime, and of course the last digit is a 6, so it is divisible by 2. 2 times 3. 2's prime, so we circle it. And actually, 3's prime, so we circle that too. So for our prime factorization, looks like we have 1, 2, 3, 4 2's. And 1, 3. Now I'm happy with that answer right there. Some people like to write it this way. Since we got 4 2's, I'll put 2 to the 4th times 3. Either way is fine. Let's take a look at 66. Some people like to tackle these as whatever number you see multiplied together to give you this. And you could do that, because we know you may be able to see that 66 is 6 times 11. If you can see that, you can start off with that. I like to always go back to the primes, because then we know what we're working with. So we'll start with 2. You ask yourself if it's divisible by 2, and it is, because our last digit is a 6. So 2 times 33. 2's prime, so we circle it. Then we work on this. We're still on the first prime, the 2. It's not divisible by 2, because my last digit is a 3. So I'll go to my next one. If it's divisible by 3, well, let's add digits together. 3 plus 3 is 6. And 6 is divisible by 3. So that means this number is divisible by 3. Well, 3 times 11. Now 3's prime, and actually 11's prime too. So this one would be 2 times 3 times 11. And that's our answer. One more of those. 64. I'll do my tree breakdown here. Start with my first prime, which is 2. And I ask myself if it's divisible by 2, and it is, because my last digit is a 4. And that'd be 2 times 32. 2's prime, so we circle it. We're still on our first prime, which is 2. And we ask ourselves if this is divisible by 2, and it is, because our last digit's a 2. And 2 times 16. 2's prime, so we circle it. We're still on our first prime. I ask myself if that's divisible by 2, and it is, because my last digit is a 6. So we got 2 times 8. And 8 is 2 times 4. Still working on our first prime. And then 4 is 2 times 2. And 2's prime, so we circle it, and 2's prime, so we circle it. So we go 1, 2, 3, 4, 5, 6 2's. And, or again, if you like exponents, you can rewrite that as 2 to the 6th power. Let me go ahead and save this. And let's see. I'm getting there eventually. Okay, start a new page now. Now we're going to take a look at simplifying fractions, and I'll do this 2 different ways. It's kind of your choice on how you want to do it. We got negative 54 divided by 60. And we're simplifying the fraction. Other ways to describe this is reduce to lowest terms. What are some other? They have many different names for the same thing. Simplify might even cover it. Okay. First method we'll take a look at is see how we have a negative here? Negative divided by positive negative. So that doesn't change. The negative just carries along. If you're good at basic numeracy, if you look at the numbers, you think the largest number divides into both of those. And 54 divided by 6 gives us 9. And 60 divided by 6 gives us 10. So that would be our answer. Well, let's take a look at it another way. If you can see that, then that's great. But you can also do the prime factorization of each number. Like if I look at 54, for example. 54 is divisible by 2. 2 times 27. 2's prime, so we circle it. Now 27 is not divisible by 2 because the last digit is 7. So go on to 3. It is divisible by 3. 3 times 9. Oops, I didn't mean to circle that one. 9 is not a prime. And 9 is 3 times 3. So, this top part we could rewrite as negative 2 times 3 times 3 times 3. Now the 60. 60 is divisible by 2 because the last digit is a 0. 2 times 30. 2's prime, so we circle it. Still on 2, and that's divisible by 2 since last digit is 0. 2 times 15. Now we're still on a 2, but this is not divisible by 2 because the last digit is a 5. So I go on. My next one is a 3. And I ask myself, is divisible by 3? And it is, because if I add digits together, 1 plus 5 is 6, and 6 is divisible by 3. So 3 times 5. 3's prime, so we circle it, and 5's prime, so we circle it. So we'll have 2 times 2 times 3 times 5. Now for simplifying, if you got the same number in this case, though it doesn't have to be a number, but if you got the same number on top and bottom, you can cancel it. Cross it out. So here's a 2, here's a 2. Here's a 3, here's a 3. Now both of them have to be up on top. These are 3's up here and 2 and 5, so nothing else can cancel. So the negative is still up there. 3 times 3 is 9. And 2 times 5 is 10. So that gives us negative 9/10. Let's take a look at this one. Negative 20 over 32. Okay, so if you're pretty good at numbers, you look at it and you see largest number divides on top and bottom. That negative carries along. And I believe 4 is the largest number. 20 divided by 4 is 5. 32 divided by 4 is 8. So our answer would be negative 5/8. Okay. If I use my prime factorization to simplify it, come over here with 20. 20 is divisible by 2. 2 times 10. 2's prime, so we circle it. We're still on our first prime, 2. This is divisible by 2 since the last digit is 0. 2 times 5. 2's prime, so we circle it, and 5's prime, so we circle it. So we'll have the negative remains there, 2 times 2 times 5. And for our 32 is divisible by 2, our first prime, because the last digit is 2. 2 times 16. 2's prime, so we circle it. 16 is divisible by 2 because our last digit is a 6. 2 times 8. 2's prime, so we circle it. We're still on our first prime, 2, and it's divisible by 2. 2 times 4. And 4 is divisible by 2. 2 times 2. 1, 2, 3, 4, 5 2's. You want to do some canceling. Again, you're looking for the same number on top and bottom. Here's a 2, here's a 2. Here's a 2, here's a 2. Looks like that's all we can cancel. So we got negative 5, and down below we got 2 times 2 times 2, that's 8. So our answer would be negative 5/8. Okay, this one has a note that goes along with it. 12x squared over 36x. Okay. Now, trying to think if I have room for the note here. Yeah, I'll just put it down here. First off, let's handle the numbers. We've got 12 and 36. And again, it's not so easy maybe in this one to see what they're both divisible by. It's actually 12. So you got 12 divided by 12 is 1. 36 divided by 12 is 3. Now, if you didn't see that to begin with, if you said, well, they're both divisible by 2, you could start off with that. Divide this by 2, divide this by 2. And then you'd see that you could do going further. So if you don't automatically see the 12, no big deal. Okay, now let's talk about the x's. If you have try that again. If you have x to a power over x to a power, this is actually any variable, as long as it's the same variable. So, but I'm writing this in terms of x to make it simpler. If you have x to a power over x to a power, then subtract the smaller power from larger power, and you will have x to that new power where the larger exponent was. Okay. So if you have x to a power over x to a power, then subtract smaller power from larger, and you'll have x to that new power where the larger exponent was. For example, if we just have an x down below, this is like x to the first. So we got x to a power over x to a power. Well, subtract a smaller exponent from a larger one. So we've got 2 minus 1, and that gives us 1, which means we're going to have x to the first power, this new power right here. So we'll have x to the first power where our larger exponent was. Larger exponent was up on top. So we have x to the first. Now this 1 here will drop, and that 1 will drop, so that just leaves us x over 3. Okay, now let's look at our prime factorization. We've got 12x squared over 36x. Okay, 12 is divisible by 2, 2 times 6. 2 prime, so we circle it. 6 is divisible by 2, 2 times 3. 2's prime, so we circle it. 3's prime, so we circle it. Now look at 36. 36 is divisible by 2, 2 times 18. 2's prime, so we circle it. 18 is divisible by 2, 2 times 9. 2's prime, so we circle it. Now 9 is not divisible by 2, so we go to our next prime in our list, which is 3. It is divisible by 3, 3 times 3. Okay. So this one looks like we got 2, 2, 3. So 2 times 2 times 3. Now we got x squared, which means we got 2 x's. The exponent tells you how many you're going to have. Now for 36, we got 2 times 2 times 3 times 3, and we got 1x. Now I'm showing this with the x's here just to demonstrate it, but I don't recommend this. I would use this note that I put down below to work these problems. Again, we're looking for the same item on top and bottom. They don't have to be numbers. So here's a 2, here's a 2. We'll cancel. Here's a 2, here's a 2. Those are going to cancel. Here's a 3, here's a 3. Those are going to cancel. And here's an x, and here's an x. So those are going to cancel. So that's what we have left. We have an x on top and a 3 down below. And you see it gives the same answer as that did. The reason why I do not recommend doing your x's this way, because imagine if you had x to the 50th power. You don't want to write out 50 x's. It just wouldn't work very well. Let me save this page. Okay. Let's look at the next one. We got 20 x to the third over 25 x to the fifth. Okay, let's first work at if you can see the largest number divides into both those, which would be 5. 20 divided by 5 is 4, and 25 divided by 5 is 5. Okay, now we have x to a power over x to a power. Remember what I said, you subtract the smaller exponent from the larger one, smallest power from largest power. 5 minus 3 is 2, so we're going to have x to the second power where the larger exponent was. Larger exponent was down below, so we're going to have an x to the second there. And that's our answer. Well, let's look at it using the prime factorization. 20. Now 20 is divisible by 2. 2 times 10. Again, I'm starting my first prime. 10 is also divisible by 2. We're still on our first prime. 2 times 5. 2's primes, we circle it, and 5's primes, we circle it. Now 25. We start with our first prime. It's not divisible by 2. So I go to my next prime, which is 3. If I add digits together, 2 plus 5 is 7, so it's not divisible by 3. So I go to my next prime, which is 5. It is divisible by 5 because my last digit is 5. And that'd be 5 times 5. And that's primes, so we circle it, and that's primes, so we circle it. Okay, so up on top, we're going to have 2 times 2 times 5 times x to the third. And down below, we'll have 5 times x to the fifth. Like I say, I'm not going to do the x's. I'm going to use my note on that. Okay, well, here's a 5. Here's a 5. So those cancel. And I guess that was it. 2 times 2 is 4. And here's a 5. Okay, we got x to a power over x to a power. Again, you subtract your smaller exponent from the larger one. 5 minus 3 is 2. And we're going to have x to the second power where our larger exponent was, which was on the bottom. And that gives us our same answer. One more of those type, and then we'll look at how to handle zeros. So we got 22 x to the 8th y squared over 12 x squared y to the 5th. Okay, first off, let's take a look at the numbers. 22 and 12, looks like the largest number divided in both of those is 2. 22 divided by 2 is 11. 12 divided by 2 is 6. Now let's look at the x's. We got x to a power over x to a power. So we'll subtract a smaller exponent from the larger one. So 8 minus 2 is 6. So we're going to have x to the 6 where our larger exponent was, which was up on top. Now let's look at our y's. We have y to a power over y to a power, so we're going to subtract a smaller exponent from the larger one. So 5 minus 2 gives us 3. So we're going to have y to the third power where our larger exponent was, which is on the bottom. And that's our answer. Okay, now let's look at it with prime factorization. 22x to the 8th y squared over 12x squared y to the 5th. Now again, we handle the variables just like before. For 22, I start my first prime 2. It is divisible by 2. 2 times 11. And 11's prime, so we circle it also. Now 12. It is divisible by 2, so 2 times 6. So on my first prime, which is 2, 6 is 2 times 3. 2's prime, so we circle it. And actually 3's prime, so we circle it too. So the top part is 2 times 11 times x to the 8th times y squared. Now when you have variables next to each other like you see here, that indicates multiplication. That means x to the 8th times y squared. Now 12 we said was 2 times 2 times 3 times x squared times y to the 5th. Okay, our guideline is the same. One on top, one on the bottom. Okay, so here's a 2, here's a 2. Those are the same. Looks like that's it number-wise. So we got 11 left here. 2 times 3 is 6. Now the x's. Again, we have x to a power over x to a power. You subtract a smaller exponent from a larger one. 8 minus 2 is 6. So we got x to 6 where our larger one was, which is on top. Over here we have y to a power over y to a power. Again, we subtract a smaller exponent from a larger one. 5 minus 2 is 3, and we got y to the third where our larger exponent was, which is on the bottom. And that gives us our answer. Okay. Let's talk about, and I'd like to do these two by examples. We got 0 over 8xy. These two problems explain how do you handle zeros. If you got 0 up on top in your numerator, 0 divided by anything is 0. Doesn't matter what's on the bottom. For that one. Okay. On the other hand, if you got 0 in your bottom part, your denominator, that's always undefined. And those would be our two answers to that. And let me save this page. And I think that was our last problem. Let me take a look. Yeah, it was.